Good afternoon and welcome to this Orolia PNT Coffee Talk on the Executive Order on PNT. We're going to start with a couple of housekeeping items. This webinar is being recorded for those who are unable to join today's meeting. During the meeting, feel free to submit questions using the question feature shown here. At the end of the meeting, we'll choose a few questions for the panel to address. If for some reason you lose your connection to the meeting, you can join again using the same meeting link. For the agenda today, we had our welcome and housekeeping, and to introduce our speakers, we are joined today by Jim Platt, the Director of the PNT Office at Department of Homeland Security, Michael O'Connor, the CEO of Satellus, and John Fisher, the VP of Advanced R&D at Orolia. In today's agenda, we'll start with an executive order overview from Jim Platt, followed by an alternative PNT for national critical infrastructure from Michael O'Connor, and preventing GNSS failure from John Fisher. After that, we'll have a brief roundtable among the panelists, and then we'll go into our Q&A from the audience, where we will be choosing questions that you have submitted during the meeting. And then we'll discuss next steps, including the GPS World webinar on June 4th. Okay, with that, I'd like to hand it over to Jim Platt for the executive order overview. Sorry, we just have a minute of delay, and we will hear from Jim Platt on the executive order overview.
Hi, good afternoon. My name is Jim Platt. I'm the Chief of Position Navigation and Timing at the Department of Homeland Security. I want to thank Orolia for inviting us to this coffee talk, and I'm honored to be presenting with Michael O'Connor and John Fisher. So why am I here today? On February 12th, President Trump signed an executive order that states, to strengthen national security and resilience, the federal government must foster the responsible use of PNT services by critical infrastructure owners and operators. So today I'm here to start following the President's direction and foster that responsible use. The first thing many people ask me when they look at the executive order is, what does responsible use of PNT mean? And is there such a thing as irresponsible use of PNT? A little bit later, I will cover a few examples of what I think is irresponsible use of PNT. But for now, I'd like to just set the stage for the discussion overall. As you will see from the discussions today, responsible use of PNT is not just about building a better GPS receiver. It spans a wide range of issues, such as how do you determine your PNT needs? How do you obtain your PNT services? Do you understand the benefits and risk of any particular PNT system that you choose to adopt, PNT system that you choose to adopt? And do you need more than one PNT system? And the last two, and probably the most important, are your PNT devices secure? And how does the PNT architecture integrate with your overall risk management process? So responsible use of PNT is really about operations and can become a good business practice and a competitive advantage if done right. So let's talk for a few seconds about the responsible use of PNT. Just this past week, there was an incident here in Washington, D.C., where a car was found in the canal adjacent to Georgetown. When they found the driver several hours later, he stated that he was driving along and he simply followed the directions of his GPS in the car, which led him down to a path, which eventually led him into the canal. This is not the first time this has happened. In past, when this has happened, they've contacted the operators or the designers of Waze and asked Google, what do you think about this? And they had a great answer, and that was, we still expect users to use all environmental information available to them to make the best decisions as they drive. So that's an example where the driver simply did not use PNT responsibility, and a good example of how there are other inputs and environmental conditions available that can help you choose an effective PNT measure. And this is not limited to people who are simply driving their cars. In China, after the 2019 rollover of GPS, we saw jumbo jets that were grounded for several days because when the systems rebooted after the rollover, the GPS signals did not link up. It caused enough alarms in the cockpit that the planes were deemed unsafe to drive. This caused both financial harm to the company that flew them and a reputational harm to the aircraft manufacturer, even though it wasn't necessarily their fault. One more example that I'll cover is the January 25th, 2016 13 microsecond jump that took place when the Air Force took Space Vehicle number 23 out of service. Alarms went off all over the world. Systems failed. Some systems failed. Some systems set off alarms, and some systems did nothing at all. So you have to ask yourself, what was the correct response to that 13 microsecond jump? Well, obviously, option number one, where the system failed, was not acceptable. But this did happen to the BBC, and for almost 11 hours, the BBC went off the air. Other countries lost cellular communications. Number two is definitely better when alarms are set off and a process is in place so that people can respond to those alarms and act appropriately. But what about number three, when the system just continued to operate? This one's a little more difficult to analyze because we have to understand what the system actually did. Did the system see the anomaly and decide things were fine after running algorithms to verify things were okay? Did the systems not see the error and continue to put out an errant timing solution? In which case the systems which were downstream were adversely impacted? Those are the types of questions that we need to ask as we talk about responsible use of PNT. It's not just about how we manage our PNT systems, but how do we ensure that we can continue with operations? So as I go on to this next slide, I'm going to highlight some of the requirements in the executive order. One of the first one is for the Department of Commerce to develop PNT profiles. When you think of the PNT profiles, I think you can think of the risk management framework that NIST developed for cybersecurity. Many of the same concepts will be applied, and NIST will initially develop an initial overarching PNT profile, and then they will work with the sector-specific agencies to help develop profiles for specific applications. We think this is a great step forward in helping businesses understand how to analyze their PNT requirements and then develop effective PNT architectures to ensure continued operations. As part of that, as NIST is developing the initial profile, the Department of Energy, Department of Transportation, and the Department of Homeland Security will each conduct pilots of identified critical infrastructure applications to do those things that I just mentioned, to work with the owners and operators to understand how or what vulnerabilities exist in their systems and how those vulnerabilities can be addressed, maybe not through the application of PNT services, but even perhaps through the operations of their systems and their downstream systems. As we move forward, one of the goals is to encourage the adoption of these PNT profiles, just as we encourage the adoption of the risk management profiles from the risk management process. As we do this, each of the sector-specific agencies will develop language to place in the contract so that if you are competing for a federal contract and your systems are dependent on position, navigation, or timing, you will gain a competitive advantage by being able to show that you are complying with the PNT profiles, that you understand the risk and have mitigated it to an acceptable level based on the application. We will continue to do vulnerability testing with the sector-specific agencies. This is a big test. A lot of agencies and a lot of applications simply do not understand the vulnerabilities that they have created. In many cases, they've integrated GPS into systems because it has been cheap, very effective, but they have not analyzed the impact should that system no longer be available. For instance, there are many material handling equipments that are autonomous operations, and should GPS not be available, those systems cease to operate, which could cause millions of dollars a day in adverse economic impacts. The next three things are a national R&D plan for PNT. We do not want to be in a position where we tell people to adopt these profiles, seek alternate sources of PNT, and then just leave it totally up to everybody. We want to partner with the private sector to develop R&D plans to encourage innovation. The United States was the leader in GPS and provided the world with a service that is, recognized as being one of the most successful technologies ever developed. We can do the same thing moving forward with other PNT solutions. As usual, if you want people to comply with things, you make them report on how they are proceeding. We owe reports back to the president every year on how well the profiles are being adopted by the SSAs. And lastly, I think that one of the biggest things is the adoption of NIST to provide UTC. It means other than they're providing it today. Right now, you can get it at the millisecond level from WWVB or through network timing, but they're going to look to make this available at much more precise levels. And on to the last slide, DHS efforts. Many of you are already involved with the conformance framework for receivers, where we're developing a guideline for receivers. So if a manufacturer, an owner-operator wants to know expected levels of performance, they can have an objective standards to go to. We're developing a risk assessment for foreign GNSS. Many people want to use GLONASS or BETAL as a backup to GNSS or GPS, but we think there are some vulnerabilities associated with those systems, as we are not always friendly with those countries, and we are concerned with the adoption of those systems within critical infrastructure. We're going to develop a toolkit for PNT, so we're making software freely available to companies who wish to use it. We'll continue our series of best practices that we've had over the past couple of years regarding GPS receivers, but expand that to other PNT systems. And last but not least, I just want to make sure that everybody understands that the real objects we're trying to get to here is it is understanding and mitigating the risk to your systems, not just to your PNT receivers. So with that, at this time, I'd like to turn it over to Michael for his presentation.
Excellent. Well, thank you, Jim. It's certainly my privilege to join you and John Fisher for this coffee talk. And thank you to Orolia for sponsoring. So as you just heard from Mr. Platt, the recent presidential executive order on PNT provides the framework for a secure future in which, among other things, GPS will be protected by backups from alternative sources of PNT. Today, I'm going to talk about some of the diverse technologies for alternative PNT that are available today to help meet the requirements of these various critical infrastructure sectors. The opening section of Executive Order 13905 includes this bold statement about the importance of GPS as the largely invisible utility for technology and infrastructure. So GPS and other global navigation satellite systems are so important that I'm going to refer to them in this presentation collectively as the primary domain of position, navigation, and timing. Alternative PNT technologies are an essential element to back up and preserve the operations of PNT-dependent systems and to safeguard our national critical infrastructure. So for this presentation, I'm going to refer to these alternative PNT systems that are capable of backing up and augmenting GNSS as out-of-domain. So there are some key reasons why out-of-domain solutions are so important. The first is diversity. Different industries have different performance requirements for timing and positioning, and likewise, different applications have different needs from the perspectives of user equipment characteristics. Things like radio receivers, network interface hardware, large or small antennas, power requirements, geographic coverage, just to name a few. So while there's no silver bullet here, the different features and characteristics of alternative sources of PNT are ideal to meet this range of complex needs and requirements. The other key reason for protecting GPS with out-of-domain solutions is robustness. So with so many types of alternative PNT technologies now available and newer ones quickly approaching the state of readiness, implementing multiple technologies is going to increase resilience by minimizing vulnerabilities and fortifying our defense against different forms of attack. That will result in a solution that's more robust than any single backup can provide. Once implemented, this will also become a virtuous cycle because competition in an open market drives the kind of innovation that's going to make tomorrow's alternative PNT solutions even better than today's. So there are many alternative PNT systems and services on the market today, or that will soon be available to users. Each has its own distinctive properties. I generally think of these in 4 out-of-domain categories. And I'm going to talk today about each of the 4 categories in terms of how we think about this. So the first category is low Earth orbit or LEO satellites. So LEO constellations have very different operational features and performance characteristics than the medium Earth orbit systems that generally make up the primary domain. Key attributes of LEOs include an increased signal strength. They're much closer to the Earth, for example, and also enhanced security. So LEO-based solutions are also, by their very nature, global, and they bring coverage to every location on the planet, offering 2D and 3D positioning in addition to precise timing. One example of such a solution is satellite time and location, we call STL, which, by the way of a quick disclaimer, that's the service that my company offers. STL is an alternative PNT solution that's in this category that's currently providing reliable services to customers around the world. There are also other solutions in this category that are either in development or that are new technologies being proposed by researchers. Another category is terrestrial wireless infrastructure. This category includes technologies that utilize ground-based radio transmitters to support operations that are within the range of those transmitters. One example is the Metropolitan Beacon System, or MBS, which is an available technology that delivers extremely accurate 2D and 3D location and timing for indoor and urban environments where GPS is either unavailable or significantly degraded. Technologies from other providers that may offer alternative PNT in the United States in the future based on signals from different types of beacons or transmitters also exist. One such example is enhanced LORAN or eLORAN, which descended from legacy LORAN technology. LORAN towers have a significantly longer range than MBS, so fewer high power radio transmitters and antennas are needed to be deployed nationwide to provide timing across the US, and adding more such transmitters could support 2D location. The next category, the next general category of out-of-domain solution is network time transfer. So technologies in this category deliver precise timing by synchronizing clocks across high-speed computer networks. For example, Precision Time Protocol, or PTP solutions, achieve clock accuracies in the sub-microsecond range. The White Rabbit protocol, which was born out of research led by CERN, is actually capable of delivering extremely precise timing in the sub-nanosecond range. Network time transfer could potentially be deployed anywhere in the world, but it generally requires dedicated or specialized high-speed connections to operate at any given location. This means that this category of alternative PNT doesn't immediately scale to wide area implementation. The technology is also limited to timing applications and doesn't provide location information. The final out-of-domain category is something I call signals of opportunity. Technologies in this category leverage radio signals that are not necessarily intended for navigation. For example, there are techniques to derive location information from signals that emanate from devices all around us, such as LTE, Wi-Fi, and Bluetooth signals. Utilizing signals of opportunity for PNT requires hardware that can acquire and process signals from across the radio spectrum. Some vendors are not only integrating these multiple radio signals, but are also merging signals of opportunity with other technologies to fine-tune 2D location and, in certain cases, providing 3D position. This opportunistic technique does require a user to be in a signal-rich environment. So, for example, there are more signals in a large city than in the middle of the ocean, thereby making alternative navigation from signals of opportunity most attractive in urban-type areas. The technology is generally limited to location, as these solutions don't currently provide timing, at least not to my knowledge. So as I stated earlier, the primary domain of PNT is really core to all of this, and it must be protected. The various solutions in these out-of-domain categories provide that protection by delivering assured PNT to help meet these diverse requirements. Now let's take a look a little bit about how these requirements can differ. So each of these sectors has been identified by the federal government as critical infrastructure, and each, as you can imagine, has its own PNT needs. So as shown here, there are many attributes that can make up the requirements for a particular sector or even a single application within a sector. Thankfully, the performance specifications and operational characteristics of the out-of-domain solutions are diverse, so they can back up and augment GPS according to the sector and application-specific needs. A principal directive of the recent presidential executive order is the development of PNT profiles for each sector. These profiles will establish the system, networks, and assets that are dependent on PNT service, and they'll also identify alternate sources of PNT and inform stakeholders of the responsible use of PNT services. So one thing to point out here is that as DoD, DHS, and DOT stated in the 2019 Federal Radio Navigation Plan published this past January, precise timing is crucial to a variety of economic activities around the world. I imagine a lot of folks in the audience realize that, but I certainly have to emphasize that when I explain that to folks outside the industry. So there are certainly diverse requirements across critical infrastructure, but the availability of precision timing really appears to be fundamental to many of them. So just to wrap up, some key points. Protecting GPS as the primary domain of PNT is really of paramount importance. Out-of-domain solutions with a range of performance and operational characteristics do exist today, and more will become available in the coming months. Together, these solutions can meet the diverse requirements of each of these critical infrastructure sectors. I think following the line of the direction that Jim described earlier that industry needs to take along with government. One observation is that while needs vary, precision timing is really one of the fundamental requirements that seems to apply across nearly all of the applications. And finally, and a really important point is we must maintain a sense of urgency. You know, the time to act is now, before we experience an avoidable black swan type event. So with that, I want to thank you all for your time, and I'd like to hand the mic over to John Fisher, who is the Vice President of Advanced R&D at Orolia.
Okay, thank you, Mike. Thanks. I think it was a great thing I'll follow here of focusing on just the GNSS signal now, because as Jim gave us an overview of the critical infrastructure and what's all the PNTs needed by the national infrastructure, and Mike has given us a look at all the alternative, as he calls them, out of domain things of alternatives to GNSS. I'm going to focus on the GNSS signal itself. We all know it's a very weak signal, but what can we do to prevent it? What can we do to prevent failures? As my mom used to say, an ounce of prevention is worth a pound of cure. So of course we're science-based, so I'm going to convert her good advice into the metric system and see what we can do about preventing failures. And so I will advance this slide here. Yes. So here's the problem. Here's what we're facing. Again, we said GNSS signals are very weak. They can be obstructed. We don't get them very good either indoors or being blocked, or they can be blocked from jamming, and jamming either intentional or non-intentional from interference, or even worse than there could be threats of like bad guys sending fake signals. We call them spoofing signals and that kind of threat. So that's the problem we're facing, and what can we do about it? Well, the first place I always say to start is at the antenna. Don't let the bad energy get into your system, whether it's interference or spoofing signals, don't let them get in. And there's a class of antennas called CHIRP antennas, controlled radiation pattern antennas. And they, let me first describe what a regular antenna, regular GPS antenna, GNSS antenna is, looks at the whole sky and sees whatever signal is coming in. if you then use a more advanced, we call a smart antenna, it would be focused. It focuses the beams just on the satellite signals and rejects unfocused or points away from the interference. And so these antennas can range from anywhere, the very simple thing, a focused beam that just looks up at a few satellites and away from the horizon, which is where most signals, most of the interference comes from. Or they can be some of these very advanced CHIRP antennas, which are tracking. They're actually tracking each individual satellite and pointing the beams towards each satellite and pointing nulls or pointing away from the interference. So I have here an example of performance from a very simple one. The one, as I mentioned, one that you're just looking up at the satellites and throwing away all the energy from the horizon. Now, of course, you throw away some precision when you do that, because at least when you're looking for positioning, some of your best geometries are achieved near the horizon. But with today's multi-GNSS signals, and you've got so many satellites in the sky, throwing away some of those is not as bad as it would have been maybe 5-10 years ago. And so what we have here in this example is a data center that was getting interference, and we put both a regular open sky antenna and a focused beam conical shaped antenna. And we see that it really reduced the amount of interference and amount of times that the interference was a problem. So very simple, very low cost, effective way of preventing problems. Another approach is in the receiver. In fact, there's some really advanced, expensive receivers out there that are able to do a lot of advanced digital signal processing techniques. But like all things electronic and software, and that a lot of these techniques now are able to be used in smaller, less expensive receivers. And the idea here being that you can, using these techniques, you can filter out certain jamming, recognize spoofing, recognize that a signal is maybe not the bona fide signal, and either avoid it or drop it or do that. So lot of things happening in this area. Let me go on to just one example way that's being done. Now, as you might be familiar with, is there are very commonly used, these are illegal, they're called privacy jammers. You can unfortunately buy these on the internet, and these are these illegal jammers work in a very simple way of where they produce a narrowband interfering signal, which the GNSS signals, they're all what's called spread spectrum. So a narrowband, they already work very well against a narrowband interferer, but then the bad guys have taken that interferer and they sweep it back and forth across the band. And so now that ruins the whole band, and it causes a loss of signal. Well, what advanced DSP techniques can do is place what's called a tracking notch filter. So track this interfering signal, and as it moves, move the filter notch and move it back and forth with it, and eliminate the interferer. And so these technique now, it's in a number of advanced receivers, and now becoming available in lower cost receivers. It's been proven to reduce the jammer negative influence. We call the jammer to signal ratio, improve it by 40 dB. So what is 40 dB? That's a radio term. What does that mean? Well, here's an example. If you had a jammer at the Los Angeles International Airport, and a jammer, 100-watt jammer, that one would take out useful GNSS coverage in most of Southern California. You see, that's the area that would be blocked. if you had a 40 dB, or actually in this case it was a 35 dB, this simulation, 35 dB reduction in that jammer, it only takes out about 1 kilometer or 2 around the airport, and that's a huge advantage. So something you can really do to prevent this type of jamming. And said it's only one type. There's the concept of filtering, digital filtering, doesn't work for every possible jammer type, but this is the most common one that's out there today. Another thought is Mike had shown in his presentation a lot of different alternative out-of-domain methods. I'd like to just focus on one more about the idea of using an internal precision clock as being one of your out-of-domain things to provide what we call holdover time. As Jim had mentioned in his presentation about the January 2016 glitch in the GPS system. I think it was a red letter day for a lot of us in the industry, of where the GPS system had a 13 microsecond jump in it. Well, systems that had an internal, what we call a holdover clock, were able to operate through that. They would notice it, maybe they would alarm on it and stuff, but at least know and still be able to continue to operate without responding to that glitch. So it's a very powerful way of preventing failures and stuff. And the point out is that there's in general in the oscillator or internal clock world, two main types are quartz crystal. In fact, a device called an oven controlled quartz crystal oscillator, an OCXO, is kind of a standard way of doing it. And then the much more advanced, very much higher stability way is using an atomic clock. Well, something in the last few years is atomic clocks have become very affordable, smaller size, and become like actually now drop-in replacements for these OCXO, the standard one. In fact, it can even use less power. So even in some mobile applications, it can be designed. So it's again, relatively new development in the last few years, that these clocks have become smaller, affordable, less power consumption, and so they become a practical alternative. It's no longer in the domain of advanced or exotic holdover clocks. Also, Jim had mentioned about, part of the thing is vulnerability testing. The DHS and actually Department of Transportation too have taken some leads on doing vulnerability testing and doing that, and so a lot of that, since we're a maker of GNSS simulators, we're aware of that. But something that, as a maker of a simulator, we want to really promote the idea, because we want to take the initiative ourselves, and we hope other simulator vendors will join us in putting in we call like an RF signature embedded into our simulators, so that a receiver can know that, okay, this is a simulator signal and not the live signal, and then as a not respond to it in a real live situation, only respond to it when it's under test. And so we think that's a very responsible thing, because as we know, if a bad guy gets one of our simulators, and we do a lot to prevent that, but of course you never can be sure, is that receivers will be able to know that, okay, this is a simulator. It's got this digital signature in it, an RF signature, or a combination of both, and be able to reject it and not be fooled by that. So that's another preventative measure that we're looking to do, and hopefully can get the whole industry to follow. Lastly, I guess another idea we'd like to consider, again, a preventative measure, is about crowdsourced detection. If we can imagine, actually, as we know right now, practically every mobile phone cellular tower has a GNSS receiver in it. That's how they get their precise time and frequency. We're seeing that in the smart grid, more substations are having GNSS receivers in them, using for their synchronization purposes and things like that. And so create a whole network of these receivers that could then, if they detect jamming or spoofing, is to report it. You're on a network and sending it back. The idea is not a new one. In fact, several years ago it came up, and the idea of maybe embedding this in our cell phones, and it turned out to be not practical. Cell phones that every battery power is at a premium on your phone, as you probably all know. When you reach the end of the day and wishing your battery was had more capacity, so this drains the cell phone and battery, and this constant detection, and so hasn't been practical. But when we are talking about cell towers, the power grid, the connected car, almost every car now having a GNSS receiver, and also the car itself being on a network. If you're on a network and you're a receiver on a network, you could start sending these reports. So this is a concept we're hoping to promote and looking to see if we can get a lot of people to consider this and work towards this. So there's just a few of what I think are several preventative measures, and take my mom's advice to prevent a problem before it happens. And with that, I guess I'll turn it back over to you, Jennifer.
Thank you, John. At this point, we have a few minutes for a roundtable discussion among the panelists based on the presentations that they just shared with us. John, would you like to facilitate that conversation?
Yes, I'd be happy to. So I guess I would like to start with just my last slide there. We talked about this idea of GPS weather reporting, and I just kind of coined a term there. I call it GPS weather reporting. The idea that if we had a system like this, I guess we from a scientific point of view, they always say if you want to control something, you have to measure it first, right? And I think actually in the pandemic, we're learning that, everyone is learning that firsthand. The idea that you really can't control a situation until you're able to measure it. So I guess I would like to put it out to my colleagues here of what do you folks think of that idea? The idea of maybe a GPS weather reporting system.
Yeah, so this is Mike O'Connor. So John, I think it's kind of a cool idea. You might even have a secondary impact that you could, sort of identify and categorize the location of potential future legato transmitters, I suppose. But we'll leave that topic out of this conversation. But yeah, I think the idea, I like, but I do like the idea of industry coming together to help solve these problems. I mean, I think what at least my observation in talking to other folks across the industry, such as yourself and others, of course, it's a small community and we all are at the same conferences and in the same conversations. It's good to see industry coming together to try to solve these kinds of problems. And I think this type of crowdsourcing to identify and potentially more quickly mitigate any sources of interference, whether intentional or unintentional, would be very positive for the industry. So we're certainly interested in that kind of activity. I think it's a great idea.
Great, thanks. Jim, it looks like you're muted maybe right now. Jim, what do you think of that idea?
So I think I agree with Mike that this is a great idea, and as we go forward, as systems start identifying anomalies in different PNT systems, the ability to report on any disruptions would be beneficial. I know we focus a lot on the GNSS system as being the primary, but if GPS doesn't work inside, it doesn't work in parking garages and those type of things. So cars and autonomous vehicles are going to start depending on other sources of PNT. So I think any time that we can identify a disturbance with PNT signals and then relay them back to people so that we can react to them, it really is needed, especially if configured in the networks that can become smart about it. Some deep learning needs to enhance the operation of the system overall. So I think this is a really great first step to focus on being over something in the future.
Yeah, and that's a good point when you said, deep learning, and I'm sure there's even, I hadn't thought of it, but the things like, artificial intelligence and that kind of thing that maybe can help us, once you start measuring and collecting, especially large amount of data, you can actually learn new things. That's great. That's great. As a other topic, I guess, Mike, in your presentation, made a really interesting point about the importance of time, time and position. And I guess as we all know that are in the industry, we know they're, so closely related. But there are cases of where, as said, you get time is rather a one-dimensional thing, but time and position is kind of a four-dimensional thing, both time and position. So there's kind of a dimensional issue. I guess I'd maybe put it to both of you, saying, in general, do you think the industry that needs to know, the critical infrastructure industry, do they understand both the differences and the similarities between time and position and the relationships there?
It's a great question, John. If it's okay, Jim, I'll take a shot at that. So I will say, when we talk to the providers of these critical infrastructure services out in the industry, I would say they're becoming more aware than they were, 2 years ago. I will say we're starting to have that conversation. 2 years ago, the conversation, whoever it would be with, we would quickly get shuffled off to somebody that was deep into a technical part of the organization, who would understand the problem and begin to discuss, hey, how important it is to solve it, but there might not be executive or management attention to the issue within those organizations. That's a broad stroke statement, but I'll just say that, if 2 years ago on a scale of 1 to 10, that was where you were going to get kind of a 2.5 response, I'd say the knob has turned up quite a bit on that. And now we're getting, I'd say a 7 out of 10 or an 8 out of 10, where, as we bring it up with these companies, I think they are recognizing that there is an issue that they have. I think often the issue is related to timing, and the fact that it's not just one timing guru within one of these large entities that understands that is, at least there's some indication that the word is getting out that, I think even executives and managers are starting to recognize, well, gee, all this equipment that we're relying on, somewhere in there's a GPS receiver, and somehow that GPS receiver is providing a timing reference usually. And gee, I've heard that if that thing stops working, that I'm going to have a problem with my business. So I wouldn't say the awareness is extreme, and certainly the subtleties of, I think folks sort of understand whether they need timing or positioning, but awareness does seem to be increasing, and intelligence around this topic seems to be increasing from what I've seen over the last couple of years.
Great. Jim, do you have a comment?
Yeah, I'd like to build on that, because we recognize that I was talking about earlier, about 1.5 years ago, that a lot of times if you went out and talked to industry, there was, you quickly were talking to a technical person, and you can get interest in the people who could make the sourcing decisions. So to that end, one of the things that we did is we worked with some private sector entities, and we put together some, we called them slick sheets, and we published them out on, if you go to CISA.gov/PNT, you can find them on there. And we developed two of these. One was designed for executive level discussions that says, do you understand the importance of timing in your organizations? And when we first talked to some executives, they gave us the standard answer. Yeah, we're good with time. Until they found out they had 50,000 time servers on their network. They had no idea what time it was, and they had no idea how bad things could go if they lost connection. So we've had great success with those documents that are available out on our website, of using them to influence leaders on the importance of time. And what we've also found out is, as other people have used them, before it was, hey, some manufacturer's coming in to sell me something. Now there's some type of reference where DHS is the honest broker, highlighting how important time is. So I think we've made some really good steps forward, and we're starting to see a lot more awareness in the leadership in different sectors.
Great, great. Okay. Well, I probably could come up with some other questions too, but Jennifer, I imagine our audience probably has some good questions. So how about I turn it over to you if you have any questions from them?
Yeah, we had a lot of good questions coming in during the meeting. I'm just going to ask these questions to the panelists in general, and any panelist could feel free to respond. So our first one, a few people asked about when a transcript would be available or a copy of the slides. We are going to have this presentation as an on-demand video afterwards, just to get that one cleared up. And then our first question, do you envision the need for the federal government to do more to incentivize owners and operators to achieve greater PNT resilience? In other words, a regulatory requirement to achieve a certain level of responsible use.
So I guess I'd be the natural person to answer that one. So we do realize that there are significant obstacles to overcome. GPS is free once you buy the equipment, and most of the other systems, or all of the other systems that we're talking about, come with some type of cost to them. So we are looking at innovative ways to encourage the adoption of the system, of alternate systems. Right now, we do not envision any regulatory requirements outside of certain sectors. For instance, the financial sector has a requirement to maintain a 50 microsecond timestamp on high-speed transactions. So we do think in certain industries it may need to be regulated, but in general, we are looking for adoption and incentives other than regulation.
Great. Yeah, and I guess I'm very American too, of like saying, wary of regulations, because it's very difficult for regulations to keep up with the pace of technology. So I think the government's kind of taking the right approach of like making recommendations and not leaning on overly regulating too much.
Okay, so
Yeah,
go ahead, Mike.
That's okay. I was just going to agree with the comments and to say though that I think providing those recommendations and finding ways to encourage industry, I think, is going to be important. And I realize it's tricky because there's potential increased cost here, but I think that does have to be weighed against the cost of something happening that ends up it could, a black swan event that could be very costly to the nation. And I think while there is some potential cost associated with these things, I think, we as an industry kind of have the responsibility to figure out how to make sure that these technologies are adopted. And I don't think they're going to be adopted without some kind of encouragement or some creative ideas. Some push. I don't think it's all going to be pulled by the critical infrastructure providers.
Okay, our next question is, do you have any comments on inertial measurement units as critical parts of alternative PNT systems?
I could start with that one. I think they're a great way. I think as I was mentioning about how a precise oscillator can be used to hold over time in the absence of GNSS. I think of the IMU, inertial measurement unit, to be the analogous thing for positioning. It gives you, keeps your position in very good short-term thing in the absence of any GNSS signal. So the combination of the two of them are great. If you lose GNSS briefly, it's a wonderful thing that'll keep you a very good position. The problem is it drifts very quickly, and it drifts exponentially. There's a double integration going on, so the errors build up very quickly. But the other amazing thing in recent years is the technology is increasing every year. The MEMS technology, the micro electromechanical systems that are now being used, making great IMUs very affordable, very high quality, and very low cost, and very small. When you think of IMU technology, used to be very expensive. It was all we had before we had GPS, but it was very expensive, and it's really growing well. So I'm a big proponent for IMUs.
Okay.
And I'd like to build on that, if I could.
Go ahead, Jim.
One of the things I would say is, I mentioned the toolkit that DHS is putting together, and one of the things that we've been looking at is something that we've implemented, which you're running off at any one time. That's actually running off your calculator with GPS so that you're still synchronized. It may reduce the attack surfaces for things like spoofing. If you're not listening to the GPS signal all the time, it may make it easier to detect the errant signal is coming in. Still a lot more work to be done on that, but we really think that using all the systems you have available to make your systems more secure and resilient is important.
I think that's great. I have just one quick comment to add, which is I think that this question is a great one because I think it highlights the differences between different national critical infrastructure sectors. So if you look at precision agriculture, for example, they rely very heavily on IMUs, and it's a core part of their solutions. If a tractor drives under a tree and they lose GPS, they can continue to operate until they reacquire. Whereas other industries that are really depending on timing and they have a static system wouldn't necessarily rely on that technology at all. So I think this one is just a great example of how different industries and different applications will have different needs. And I certainly agree with John's comments and Jim's comments that they where they fit, it can be tremendously helpful.
Okay, thank you. Our next question is, do you see any low-cost controlled radiation pattern GNSS antennas being developed for the auto industry where cost constraints are significant?
I don't know of any. I guess all I could say is I'm hopeful that there is, because as you pointed out, there's low cost is very important, and but the auto industry has the advantage of being so pervasive and having such a large base that they can invest, or someone, a manufacturer. We don't make CHIRP antennas, we don't make controlled radiation antennas, so I'm not an expert in that area, but I guess I would say it seems to me possible, and I guess I'm even hopeful that we will see really low cost things happening in CHIRP antennas, being especially with demand pull coming from just that industry, as that question points out.
Okay, then our next question is, how can industry best contribute to the administration's implementation of the executive order, and is there a formal process for providing feedback?
So I think some of the best ways that industry can participate is the National Institute of Science and Technology, as they develop the PNT profiles, will go out with a public announcement and do public sessions to get input from the private sector on what a PNT profile should look like. So if you can participate in those sessions, I think that's the initial thing that we can do. And then once again, just as people are developing the risk management procedures within the private sector, ensure that PNT is, if you are dependent on PNT, ensure that PNT architecture is included in the overall risk management profile. You may be able to manage the risk pretty well with GPS based on your industry, but it really should be a conscious decision and not something left to chance.
Okay, our next question is, affordable and large volume atomic clocks seem to be far off in terms of being practical. What companies actually produce them at scale?
Okay, I guess since we're a company that is producing, what's kind of new to us, so where we're starting to make affordable, at least what I would say are affordable ones. We're starting to scale up on that, but I believe also the company Microchip makes what's been popularly called the CSAC, the chip scale atomic clock. I guess affordability is all in the eye of the beholder, kind of thing of what, they are more expensive than a typical quartz, high quality quartz one, but I would say they are coming down in cost. So those are the ones I'm aware of, but whatever it is today, I would expect, because I know we're seeing that our ability as we scale up, that we can make our clocks more affordable as well. So I would expect even if you don't think they're affordable today, I would expect them to be affordable in the coming years.
Okay, our next question is, why would we not use cell phone towers for GPS weather reports? They all have GPS receivers and they all have communications capability to transfer health measurements to central locations.
Okay, I'll take that one again, because I guess that was in my presentation. I probably didn't do a very good job in my presentation then, because I guess that's exactly what I was proposing, that we would use. Maybe I confused it. I say you wouldn't use the phone itself because the phone uses up battery, but you would use the tower. So now, of course, there's hundreds of phones for every tower, so you'd have gotten more data points from the phone. I think that's what I was trying to point out, but that's not practical. But yes, I guess what I was proposing is, I would say propose the several places are every cell tower, every car that's on a network. But the cell tower already has the advantage of having both the receiver and being on the network, so it's a natural there. I also said the grid, the smart grid, the fact that now the grid is there's a network being added to our power grid, and yet every substation is having at least many of them having a GNSS receiver. So you've got hundreds of thousands of substations that could be these points of data collection. I also had listed on my slide there something, because we're very familiar with every 911 call center. There's thousands of them in the United States. For our non-US people to know that we have an emergency call system, like in Europe has 112, and we have these things. But every one of our 911 call stations have a GNSS receiver at them for the precision time, for making sure that they're all synchronized. And so there's another place of where they can, in fact, these are government-owned facilities that already have they can already be doing that GPS reporting. So thank you for that question, whoever asked that, because if I had misled you on my presentation, I was really looking to point that out. That I think is the ideal place. Cell towers is the ideal place.
Okay.
Hey, John, if I could expand on that for just a second. We were recently talking to an organization about doing that for their fixed place timing receivers because they were getting a lot of interference. And so we recommended some best practices where they put in ground nulling antennas or choke ring antennas and or reposition their antennas. And suddenly they weren't seeing a lot of the interference. So, this is one of the things that is if we are careful about how we install our antennas, we may be able to avoid a lot of the interferences taking place in the first place. And we may not see it to report it.
Yeah, good point. Very good point.
Okay, I think we have time for one more quick question. When do DoD and DHS plan to issue draft contract clauses on PNT under the executive order for public comment? And when might such clauses form part of the requirements that bidders must meet for U.S. government contracts?
The requirement in the executive order is to do that within a year. I don't think it will take that long for us to develop those initial contract languages. But if I wanted to foreshadow what they would say, it would focus on, is there a risk management process in place to ensure resilient position navigation and timing, if that is an integral part of the service that's being provided.
Okay, thank you. I think that's all the time we have for Q&A. So we'll move on to our next steps. And our next step out of this meeting is that we'd like to invite you to a GPS World webinar coming up on June 4th about protecting critical infrastructure with resilient timing and synchronization technology. So we really enjoyed having you here today on this conversation. Again, this presentation will be made available on demand by video afterward. And our next event then is on June 4th at 1 p.m. with GPS World, and we hope to see you there. So to everyone, our panelists and the audience, thank you so much for joining us today for this Orolia PNT Coffee Talk, and we hope to see you again on June 4th.